You think you know the shape of our planet, right? I mean, every photo from space, every sunset, it all points one way.
Yeah, it seems pretty settled.
But what if?
Yep.
What if it wasn't? What if that's all part of a massive deception? Today, in the deep dive, we're diving headfirst into, well, one of the most surprising key conflicts out there. Is the Earth really a sphere, or could it actually be a flat disk?
It's an idea that really challenges, our basic understanding of everything, and it's gained surprising traction recently.
Absolutely. So today, we're going to look at a whole range of sources. We've got scientific papers, philosophical takes, real-world experiments.
And importantly, the arguments from flat Earth proponents themselves, we need to understand their perspective too.
Exactly. Our mission here is to really unpack the main arguments, look at the history, maybe touch on the psychology behind it, and figure out why this idea persists, even grows in our information age.
It should be pretty revealing. It's more than just geometry, really. It's about belief, evidence, how we know what we know.
Okay, let's dig in. So maybe start with the history. I think a lot of us have this image, right, of people in the Middle Ages believing the Earth was flat.
Right. The Columbus story proving them wrong.
Yeah. But the sources tell a different story, that whole idea about widespread medieval flat Earth belief. Apparently that's mostly a myth itself from the 19th century.
That's right. It's kind of ironic, isn't it? The ancient Greeks, people like Pythagoras, Aristotle, and definitely Eratosthenes. They weren't just guessing.
Eratosthenes measured it, didn't he? Way back when.
He did. Calculated the Earth's circumference back in the 3rd century BCE, and he was remarkably accurate. So this idea of, universal medieval ignorance was largely cooked up later, often to critique religious thinking at the time.
Okay, so the common story is wrong. Fascinating. But the modern flat Earth idea, that had to start somewhere. Where did that actually come from?
Well, our sources point to the 19th century again. A British inventor, Samuel Rowbotham.
Rowbotham, right.
He's really key. He did experiments, the famous Bedford Level 1 wrote books, and basically laid the groundwork for the whole modern movement. His model, Earth as a flat disk, Arctic at the center.
And Antarctica.
And an ice wall.
Yeah.
Circling the whole thing, keeping the oceans in.
Okay. And this didn't just vanish. There was a Flat Earth Society later on.
Yeah, it was reestablished in 1956, grew under people like Charles K. Johnson. But honestly, the massive resurgence we see now, that's the internet.
Ah, yes. Social media.
Totally. YouTube, Facebook, Twitter, viral videos. It's been huge for spreading the theory, especially in the 21st century. And interestingly, some data suggests a higher percentage of younger people, millennials and younger, express doubts or even belief in it.
So the internet isn't just connecting people with niche ideas.
It's actively amplifying them, creating these, echo chambers. You find a community, your beliefs get reinforced, misinformation spreads fast. It's a powerful dynamic.
Okay, so let's get into the model itself.
Yeah.
If it's not a sphere, what is it, according to proponents?
Well, the core idea is a flat circular disk, about 40,000 kilometers across.
With the North Pole right in the middle.
Exactly. And surrounding the entire edge is this massive ice wall, what they identify as Antarctica.
And its purpose is?
To hold the oceans in, stop them falling off the edge. Some even claim it's, guarded, to stop people finding out what's beyond.
Right, okay. So what about the sun and moon? How do they work if they're not orbiting a sphere?
In this model, they're much smaller and closer. They hover above the disk, moving in spirals.
So night isn't the sun setting below the horizon?
No, it's just the sun moving further away in its spiral path. And seasons happen because that spiral path shifts, moving closer to the center or closer to the edge over the year.
Great. This next bit is pretty fundamental. Gravity.
How
does that work on a flat, potentially infinite plane?
Well, here's a major point of departure. They generally reject gravity as a force pulling things down.
So what holds us down? Why do things fall?
The belief is that the entire Earth's disk is constantly accelerating upwards. At 9.8 meters per second, squared the same number as the acceleration due to gravity. This upward rush, they say, creates the feeling of weight.
Upwards?
Yeah.
Constantly. What's pushing it?
Sometimes it's attributed to something like dark energy. It's often not fully specified.
Wow. Okay. And if the Earth is flat and accelerating up?
Yeah.
What does that mean for space travel? NASA? All those pictures of Earth from the moon?
All faked, according to the theory. Every satellite launch, every spacewalk, every photo from orbit, elaborate hoaxes, filmed in studios.
Some even mention filmmakers like Kubrick or James Cameron being involved.
Yeah, those names come up. The idea is this grand deception, often described using the Russian term raspolbabla.
Raspolbabla. What does that signify?
It basically means a massive embezzlement scheme, a colossal waste of taxpayer money funneled into faking space travel, or maybe it's about control, keeping the population believing in the globe model for some hidden reason. That concept, the Raspelbabla, is often central to the conspiracy aspect.
So it's not just a different model of physics, it's a whole conspiracy narrative woven together.
Exactly, a complete alternative reality, in a sense.
Let's pivot to evidence. What do flat earthers point to? Things they can see. Rowbotham's experiment you mentioned.
Right, the Bedford-level experiment from 1838. He claimed he could see a boat's flag over a 10-kilometer stretch of calm water, which he argued wouldn't be possible if the Earth curved significantly over that distance.
And people still use similar arguments today, like looking across lakes.
They do, or observations from flights. Some travelers note that a spirit level on a plane doesn't show the bubble constantly shifting, which they interpret as the plane flying level, not dipping its nose to follow a curve.
Okay, that visual stuff.
Yeah.
Wait, it sounds convincing on the surface. What's the scientific take?
Well, the key thing Rowbotham missed, and what affects many similar observations, is atmospheric refraction. A physicist, Kirill Boldarev, explains this well.
Refraction.
Right.
Like a mirage.
Essentially, yes. Light bends as it passes through different temperature layers of air, especially near a flat surface like water or ice. It can make objects appear higher or visible from further away than they would be if light traveled in perfectly straight lines. So the very thing they point to as proof of flatness is actually an optical effect happening because of the conditions over a curved surface.
So our eyes can genuinely trick us in these situations. Are there experiments that account for this?
Absolutely. Like the Rybinsk Reservoir experiment. Researchers put a camera very low, near snow level, and watched a light on a distant snowmobile. First, it was just a glimmer, then it rose into full view as it got closer. That directly showed the light source was initially hidden by the curve of the Earth.
This seems pretty clear. What about the airplane argument then? Why no constant nosediving?
A pilot instructor, Dmitry Polovkin, addressed this. It's simple physics, really, gravity. The plane is constantly being pulled towards the Earth's center, which keeps it naturally oriented parallel to the surface below it.
So it's not fighting the curve, it's just flying within the gravity field.
Exactly. And the Earth is just so huge. The curve over the distance a plane travels in, say, a minute, is incredibly tiny, imperceptible from inside. You wouldn't feel it, and the plane's instruments wouldn't register it as a dip.
Okay, so the visual arguments have scientific explanations. But flat earthers also bring up geographical points, right? Like rivers.
Yes, there's an argument mentioned by musician Yuri Loza, for instance, about rivers like the Volga. It drops about 100 meters over 2,500 kilometers. The claim is, on a sphere, the curvature would be too much for water to flow uphill effectively over such a distance with only a 100-meter drop.
How does that stack up scientifically?
It doesn't really hold up. Rivers flow downhill relative to the local gravitational field, not relative to some absolute flat plane. A 100-meter drop over 2,500 kilometers is a very gentle but definite slope on the curved surface. Gravity ensures water flows along that slope.
And what about the poles? Laza also mentioned Antarctica being much colder than the Arctic, which he thought contradicted the sphere model.
That temperature difference is well explained by factors like ocean currents, landmass distribution, and atmospheric circulation on a spherical Earth. It's not anomalous. And the core flat Earth idea of Antarctica being an ice wall instead of a continent...
That contradicts actual exploration.
Massively. People have reached the South Pole, crossed Antarctica. It's a continent. Plus, phenomena like the 24-hour daylight of polar summer and 24-hour darkness of polar winter happen at both poles. That's only possible on a tilted, rotating sphere orbiting a sun. On a flat disk with a circling sun, you couldn't get 6 months of continuous daylight or darkness at the edge or center.
Okay. That also connects to flight paths, maybe. People see flight routes like, say, Sydney to Santiago, Chile, looking like huge curves on flat maps.
Right, and they say, why fly that huge curve? Must be hiding something.
But that's just map distortion.
Exactly. It's called a great circle route, or an orthodromic line. It's the shortest distance between 2 points on a sphere. When you flatten that sphere onto a 2D map like the common Mercator projection, that shortest spherical path looks like a long curve. But it's actually the most direct route for the plane.
Like peeling an orange and trying to lay the peel flat, it distorts.
Perfect analogy. And pilots actually demonstrated this. There was a flat-out hero challenge where a pilot flew a specific triangular route in a simulator legs requiring 90-degree turns relative to the starting direction, proving it's easily possible on a globe model, but geometrically impossible on the standard flat Earth map.
So beyond Earth itself, there's this whole cosmic dimension to the theory. The idea that everything we see from space is fake.
Yes, that's a cornerstone. Videos like astronaut Tim Peake playing with a water bubble in zero-G, they claim it's faked. Green screens, wires, maybe even CGI.
And the stars, they have a different view on those too.
Yeah, some do. One proponent, Andrei Velikanov, tried to calculate the distance to Polaris, the North Star, using simple trigonometry, assuming it was directly above the North Pole on a flat plane. He came up with only about 5,888 kilometers.
So stars are really close, like inside a dome.
That's the implication, that the stars are just lights on some kind of overhead structure, a greenhouse or dome. Velikanov even suggested the moon looks artificial, pointing to lines or spots on it.
What do actual astronauts and scientists say to the faked videos claim?
Well, astronaut Mikhail Kornienko, who actually flew with Tim Peake, basically laughed it off. He explained they use various tools for experiments, complex work, not Hollywood tricks, and he made a crucial point. The sheer number of people involved globally in space programs, engineers, scientists, technicians in multiple countries, makes a decades-long conspiracy involving fake launches and landings virtually impossible to maintain. Someone would talk.
And we don't even need a rocket to see the curve.
Nope. High-altitude balloons, even going up to 30 kilometers, show a distinctly curved horizon. That counters the idea that all curved images are just distorted fisheye lenses.
Okay, and the calculation for Polaris being super close.
That's based on flawed geometry, according to astrophysicist Victor Sharagan. Velikanov treated light rays from Polaris as if they diverged significantly over earthly distances. But for something light years away, the incoming rays are effectively parallel. Using simple triangulation designed for close objects gives a meaningless, finite answer for something astronomically distant. It's like trying to measure the distance to the sun using two sticks a meter apart.
So the math is just wrong for that scale.
Yeah.
And the dome idea.
That falls apart when you consider things like exoplanets. We can observe planets orbiting other stars hundreds or thousands of light years away using powerful telescopes. Those observations are happening far beyond any hypothetical dome over the Earth. It points to a vast cosmos, not a small enclosed system.
This really gets into the psychology of it all, doesn't it? Why hold on to these beliefs so strongly despite the evidence? It seems like a classic example of pseudoscience.
It really does fit the pattern. Pseudoscience often presents itself as scientific, uses jargon, but crucially lacks key elements. Testable predictions, openness to revision based on evidence, repeatability, and adherence to the scientific method. Instead, you see,
A tendency to stick to the belief no matter what.
exactly, rigid adherence, rejecting criticism, relying heavily on anecdotes or specific interpretations of evidence while ignoring contradictory data. Often there are sensational claims and appeals to some kind of hidden or suppressed knowledge.
And it often seems linked to a broader distrust, right? A conspiracy mindset.
Very much so. A deep suspicion of authority, government, science, media is common. The flat Earth belief is often part of a larger narrative where they are lying about everything. Denying the globe is seen as rejecting this massive conspiracy, often tied back to that rascal-babble idea that it's all about controlling us or embezzling money.
Which raises that interesting question. How do people use GPS every day, which relies entirely on satellites orbiting a spherical Earth, and still maintain the belief?
That often comes down to things like compartmentalization, or perhaps believing the GPS signals are faked too, or come from ground towers, not satellites. Cognitive biases play a huge role.
Like confirmation bias.
Definitely. Actively seeking out only information that confirms your existing belief and dismissing or rationalizing away anything that contradicts it. You see a flat horizon, confirmation. You ignore the sunrise mechanics that don't fit.
And maybe the Dunning-Kruger effect, where less knowledge leads to more confidence.
That's often cited too. Someone with a very basic grasp of physics might feel overly confident in spotting flaws in complex scientific models they don't fully understand, dismissing experts who have spent careers studying it.
There's also a social element, isn't there? Finding a community.
Hugely important. Belonging to a group that shares these beliefs provides validation, comfort, a sense of shared identity, maybe even feeling special for knowing the truth. To question the belief, then, means risking isolation from that community, which is a powerful deterrent. It can feel almost therapeutic to be in the know.
And this rejection of scientific consensus, it's not just about the Earth's shape, is it? There are wider dangers.
Absolutely. That's a critical point. Scientific consensus isn't just majority opinion, it's the accumulated weight of evidence, rigorously tested and debated by experts over time. When people start rejecting that process for one topic, it can easily spill over.
Like with vaccines or climate change.
Exactly. Or relying on unproven medical treatments. It fosters a general distrust of expertise and evidence-based reasoning, and sometimes, tragically, it has direct, fatal consequences like Mad Mike Hughes dying in his homemade rocket trying to reach the edge or prove flatness. That erosion of critical thinking is a serious concern.
So we've covered a lot of ground today, no pun intended. We looked at the surprising history, the modern resurgence fueled by the internet, the details of the flat Earth model versus the scientific understanding.
We saw how proponents use visual cues, geographical arguments, and claims of space fakery, and how science addresses those with concepts like refraction, gravity, map projections, and astronomical observation.
It really underscores the importance of critical thinking, doesn't it? Sifting through information, understanding the scientific method, evaluating sources in this, well, very noisy modern world.
Yeah, these key conflicts, exploring why people believe what they believe, it tells us a lot about ourselves and how we navigate knowledge and misinformation.
So here's a final thought for you to consider just hypothetically. If Earth really were flat, think about the unbelievable power NASA or whoever is behind the conspiracy would actually possess. Not just faking photos and videos.
But managing to send probes and even people from that flat disk all the way to a demonstrably spherical Mars, that level of deception and technological mastery would be staggering.
Makes you think, doesn't it?